So let me share my screen. Guys, are you able to see my screen now? So for today's agenda, so we are going to discuss about the DevOps practices. So for yesterday, we were discussed about what is the DevOps and why the DevOps will come into the picture. For today's agenda, so we are going to see about how the DevOps will see that. Okay, how the DevOps will can able to see that. So this is very important, guys. Okay, we can able to see how the DevOps will come into the picture. So coming to the DevOps practices, so we have the continuous integration, continuous delivery. So these are the four practices, four pillars of the DevOps, guys. Okay, continuous integration, continuous integration, continuous delivery, configuration management, and continuous monitoring. Okay, continuous monitoring. Continuous monitoring. Guys, please mute yourself. Okay, continuous monitoring. So clear, everyone. So when if you go to the continuous integration, continuous delivery, configuration management, and continuous monitoring. So these are the four pillars of the DevOps, guys. Okay. So in this dev process, so what are the tools? So we are going to discuss. What are the tools? So we are going to discuss. The first one is in the continuous integration, we are going to discuss about Git, Maven, and Jenkins. Okay, and coming to the continuous delivery, so we are going to discuss about Docker and Kubernetes. And configuration management. So this is configuration management will help us to configure the resources, guys, to configure the resources. Okay, so to configure the resources, how we can able to configure the resources. So that is called it as a Ansible. Ansible is very powerful tool. And coming to the continuous monitoring, so we are going to see about the CloudWatch, because most of the application, 90% of the application nowadays, they are migrating them into the cloud, correct? So that's why we are going to work on the CloudWatch. And along with that, so we are also discussing some kind of scripting. Okay, scripting is nothing but YAML script, JSON script, and Groovy script. Okay, Groovy script. And we are also discussed about Linux environment. Linux is also very important, guys. Okay, see, whenever we are most of the times we are using the Windows environment, but coming to the real-time scenario, so most of the servers should be there in the Linux environment, right? So for this purpose, so we are going to see the Linux at least 20 plus commands. Okay, 20 plus commands we need to aware of it. So basic commands, how we can able to act, how we can able to work on it, how we can able to work on it. So this is very important, how we can able to work on. And one more important, guys, so along with this, we need to cloud is also very required. The cloud we are going to discuss AWS. In that 10 plus services we are going to cover. And one more important, whoever is asking the questions on the cloud, you can easily answer. You can easily answer. You can easily answer here. Okay, na? So these are the toolkit. We are going to see that. Now coming to the process one by one. So continuous integration, we already know that, right? So if anyone missing for yesterday's session, so yesterday was only for theoretical session, because initially 1 or 2 sessions, this is the theoretical sessions, because I would like to give some kind of real-time scenarios and terminologies to you guys, so that everyone can aware of it. Okay, and continuous integration. Yeah, so continuous integration is a software development practice where the developers regularly merge their code changes into the centralized repository after the automatic builds and test runs. So this is nothing but continuous integration. So if you understand very difficult, okay, just remember one point. If we want to automate all our manual process, If you want to automate all our manual process, then we can call it as a continuous integration. And as per that, and we are also having, if you want to automate, so guys, please mute yourself. I am requesting one more time. I am requesting one more time. Please mute yourself. Yeah, right. So to automate all kind of manual process. So this is very important. Now coming to here, guys, I will show you how it should work in the continuous integration one more time. So what is the meaning here? When the developers, right? When the developers are working, on it, right? So when the developers are commit the code into the different types of repositories, then it should be changed. Then it should be automated builds and testing to the process. So this is very important. Now I am going to use a small diagram to you guys so that everyone can aware of it. So how it works on the continuous integration. Okay, so let's take one small diagram here. Let's take one small diagram here. Yes. So yeah. Yes, this is called it as a Git. So first one is Git, guys. Okay, so we are going to use for the Git. So Git is nothing but it's a repository. So where we can able to store all kind of application data to keep our application data to keep. Okay, so this is called as a Git. So in this Git, so we are going to see that to keep application data. Okay, to keep application data. So it can be anything, guys, application code, everything. Okay, so next one is we will go for the build. So as per the process, build is nothing but what we can do, whatever the code is available, it should be using by using the some kind of tool that is called as a Maven. So what here to compile the project and packaging the project, to compile and packaging the project.
గుడ్ మార్నింగ్ అండి VCUBE నుంచి అటెండ్ అవుతున్నారండి?
Yeah, 11 members join. Yeah. Guys, please mute yourself, guys. Please mute yourself. Yeah. Okay, so to compile and packaging the project. So this is very important. Yeah. Okay, to compile the project and packaging the project. What is the meaning of compilation, guys? What is the meaning of packaging? Correct, that is more important. See, the project is nothing but a multiple files. A project is nothing but a multiple modules. So when we are working on the real-time scenario, so we have to compile all the configuration and we have to work on it. So this is very important. This is very important. And one more important scenario. So once the compilation packaging is project, so then we have to combine them into some other shared location. So that shared location will be either it should be Nexus or JFrog. So this is the artifact tools. These tools also we are going to cover. Nexus, JFrog. Okay. And along with that, we are also discussed about SonarQube. SonarQube will help us to get the code performance, right? So here I'm just writing here to store all kind of packages, So you might be doubts, what is the package? The package is nothing but whatever the code we have to combine into one package. Those packages should be var file or jar file. Okay, and we are also one more thing, that is the ER file, enterprise archive. Right now we are not using ER functionalities, guys. Okay, because so whenever we are using the EJBs, the Java bins, during the time the ER files is working, but now either it should be var file or jar file, web application archive or Java archive. To store all kind of packages and also to check the code performance. To check code performance. To check code performance. So this is very important. to check code performance, guys. So after that, what we can do? So we directly deploy them into the server, correct? So here I am taking any of the server, guys. Web servers or application servers. Web servers or application servers, I can able to take it. Web servers or application servers, I can able to take it, correct? So I'm just taking here, there is a server here. Right. So let us take, this is our Tomcat. So this is the traditional deployment only. So we can say the traditional deployment. So nowadays the industry changed it to two things, guys. So traditional deployment is traditional deployment, and one more thing, containerized deployment. Containerization deployment. Okay, so first thing is we are going to understanding about the traditional deployment. Okay, so in this traditional deployment, so what we can do, so we are going to direct physically deploy those packages into the Tomcat server. Physically we are going to deploy them into the Tomcat server. So that is called it as a traditional deployment. Okay, so let's take, so this is your my app, I just deployed. Now what happened? So as of now, this is a manual process, right? So when they are manual process, who is working on the Git? Git is working on, the developers are working, and application engineers are working, and operation people is also working. Coming to the Maven, so here the developers are working, and coming to the Nexus and SonarCube, operation people will push all kind of packages and to check the code performance. I forgot to write, to check the code performance. To check the code performance. Okay, so this is called as a to check the code performance. So here the operation Tomcat server. But what was the problem here when we are doing the manual process? So think about the yesterday session, right? So when we are doing the manual process, so we are having the integration issues are coming. So that's why instead of waiting for that till first day itself, we have to automate each and every process. So when we are going to automate the process, that is very important. Can anyone tell me when we are going to automate the process? So whenever the developer, right? Whenever the developer will commit the code into that, whenever the developer commit the code, right? At the end of the day, every developer will commit the code into the our repository. So automatically it should be executed. So clear everyone? Now what I can do? So the pipeline will flow like this, like this, like this, like this, like this. Got it? So who will responsible to automate each and every process? So here the DevOps engineer will come into the picture. So this tool is nothing but Jenkins. Okay, so here what we can do, so we are just manual, whatever the manual actions are there, we just automated to the step wise. So first step what we can do, so in the first step, so we are going to get the code from repository, and second step, guys, to compile. So instead of that, to packaging the project, so we insert, for example, if we want to go for packages, first we need to compile it, and then we need to validate the process. So this is very important. So next one is we need to store all kind of packages, Nexus and JFrog and SonarCube. So this is also very, very important, guys. So what they can do to store all packages. So please make sure in the real-time scenario, so whatever the packages we created, everything we can able to store into that, to store all packages into Artifactory servers.
అలా ఇంకా జాయిన్ అవ్వలేదా అండి?
Artifactory servers.
Okay.
Artifactory servers. Okay. And next one is fourth one. So what we can do? So we are going to deploy them into the Tomcat server. Okay. So this is the process. See, so whenever the automated, what will happen? So we can easily write. So this is one-time activity. So every time when the developer is updating new kind of functionality, they can able to check in, they can able to check out. So that's why the continuous integration will come into the picture. So while seeing the diagram clearly, it is a software development practice. Okay, it is from the development side. So where the developers are regularly merge their code. So please merge the code is nothing but they can able to merge into the code in the master repository, right? So automatically it should be compiled, it should be validated. And there is a one more definition I'm telling, right? So to automate each and every manual process in that delivery process, we can go for the continuous integration. So what are the tools will come under the continuous integration? So here, so we will come under Git, Maven, and Jenkins. As I told you, the continuous integration will help us Git, Git, Maven, and Jenkins. And along with that, we are also discussing about Nexus and SonarQube. So Nexus and SonarQube, these two tools also, so we are going to cover. So total how many tools will come under continuous integration? 1, 2, 3, 4, 5. So for these 5 tools, we are going to discuss in the initial days. Okay. So after that, there is a one more process, guys, that is called as a continuous delivery. So the delivery is nothing but a software development practice where the code changes are automatically built, test, and prepared for the release to the production. So this is very important. See, right now this is a one server, but think about the multiple server. So in real-time scenario, you should not deploy our application to single server, correct? We should not deploy our application to single server. So we can use this application to n number of server because of the high availability. Now we will see that. So how the continuous delivery will work. Okay. Continuous delivery will work and what are the tools we have. Is it clear everyone as of now? Or still any confusions? Guys, please let me know if you have any confusions till now. If everyone is clear, then we will go for the continuous delivery. Guys, clear na?
Hello.
Yes.
Sir, I missed yesterday's class.
Yeah, no problem. So just go through the recording. Okay, they will provide the recording. So that is a theory only. So you can spend 30 minutes time to go through the recording and you can understand very clearly. Okay, na? Arna?
Okay, sir.
Yeah. See, because yesterday's session, today's session is totally different. Okay. So I'm just explaining the process. Yesterday we didn't discuss these things. Okay, na? Yesterday only we discussed about what is the necessity of the DevOps. Why the DevOps will come into the picture. That's it.
Okay.
Yeah. Right. So now coming to the continuous delivery, guys. So when you're working on the continuous delivery, what Artifactory servers? Yeah, Dharani. So coming Artifactory servers are nothing but see, we created the packages in the Maven, correct? So it should be varfile at jar file. We need to store in some kind of centralized area. So that is called as Artifactory server. So here we are using the tools Nexus or JFrog. Clear, Dharani? Clear?
Can you please explain again, sir? I don't understand.
Sorry. Yeah.
I can't understand again.
Okay, fine. Let me understand clearly. Okay. See, usually what happened, we are having the code, correct? Application code. After that, we are compiling and packaging the code. So when we are compiling and packaging the code, so where the packages are available, the packages are available in your local system only, correct? In your local system only. Let us assume my application is application.var. So it is available in my local system. But if I want to use this system, if I want to use these packages in outside of the application or in the other application, so how we can do that? Correct? That's what that's why we need to use some kind of shared tools. So this is called as a, if you want to share the tools now, we can just push that. We can just keep saved into this WAR file into this location. Let us take, this is the Nexus Artifactory server. So within the Artifactory server, we can make it as like this package, my app. Under the my app, we can able to store the app.var. Suppose in future, if I want to use this application, you no need to compile again. So just you can use this you can take this from the Artifactory server and you can use in the some other application. Got it, na? Understand?
Yes, sir.
Okay. So for this, we can use the reusability. We can simply understand the term is reusability. So whenever if the packages are reusable in other application or in other services, so then we will come under Artifactory servers. So what are the best Artifactory servers in the market? So there is a Nexus and JFrog, right? And now coming to the continuous delivery, guys. In the continuous delivery part, so we are going to see so how we can able to do that. So what is the definition of the continuous delivery? Whenever if we want to deliver our application, we have to make the consistency in all the server. So in the real-time scenario, we are not deploying our application into n number of servers. Sorry, we are not deploying our application to single server. So instead of that, we will go for the n number of server for high availability. Let us assume we have the one production environment. So we have the 4 servers. So this is the server 1, server 2, server 3, and server 4. Yeah, these are the 4 servers are available, right? So server 1, server 2, server 3, server 4. So my agenda will be, let us do like that. This is called as a web server 1, web server 1, web server 2, web server 3, web server 4. Okay, so we are having the 4 servers, guys. Now what we can do, so we need to deliver your application. So if I want to set up your workspace, if you want to set up your workspace, then what we can do, if you want to set up your workspace, if I want to set up in your workspace, so there are a couple of things will be required. What are the things are required here to set up the workspace? The first thing is to get necessary softwares. Yes or no? Let us suppose you guys are might working on the mini projects, correct, in your academics. Whoever is completed BE, BTech or MCA, you might be working on the academic projects in the software, and as well as whoever is working on the real-time scenario, right? So if we want to set up the workspace is nothing but we have to combine all kind of tools in that. Okay, to get the necessary softwares, and to get application deployed them into the Tomcat servers, to get the deployed them to the Tomcat server, and finally maintenance of the so we can say that middleware services. Middleware services. See, if you want to set up your entire workspace, it is taking one time. So for discussing for layman example, guys, I'm explaining very clearly. Okay, in the real-time scenario, we are not deploying our application into single server. So what will happen if you are deploying into the single server? Okay, so automatically, if you are deploying them into the single server, your application will be crashed, correct? So all of a sudden, if your application is down, so the users will not able to access our application. Then we can go for the more than one server. So when we are deploying our application to more than one server, what is the advantage here? So even if one server is not available, still the users can able to access one more server. So that is called as a high availability, right? So here let us assume the layman example for your understanding. So blindly, whatever the servers we created for any kind of environment, you need to make the consistency to how we can able to achieve this consistency. Let us take, if the server is taking 2 hours of time to set up all kind of workspace, the same kind of process we need to do in the web server 2 as well. Same kind of process we need to do web server 3 as well. Same kind of process we need to do web server 4 as well. But can you tell me, for 4 web servers that is fine, for 4 into 8 hours. Let us assume your client wants 10 servers. So his client will happy to spend this much of time, 10 into 20 hours only for configuration of the workspace? Is client will happy, guys, or not happy? Is client will happy or not happy? Guys, clear everyone? See, we have the 4 servers and we need to deploy our application. Okay, when we are deploying application, we need to set up our workspace. So within this workspace, so we need to set up necessary tools, necessary configuration. It is taking 2 hours time. Again, the same process we need to do in the web server 2 as well and web server 3 as well. And if you want to do like that, is client will happy? The client will not happy, guys, because so this is taking more number of time, correct? More number of time. Yes. So in that scenario, then how we can able to handle the situation? And here, the DevOps engineer will come into the picture, guys. The DevOps engineer will come into the picture, and he's using some kind of containerization concept. So here, the containerization concept will come into the picture. Containerization concept will come into the picture. Okay. So in that scenario, how it should work? How it should work, correct? So whatever the configurations are doing, we can just make it as a images. So let me tell you the layman example. So let us assume we are having the 4 servers. We are having the 4 servers. These 4 servers we are keeping into the Dilshuk Nagar. Okay, let us assume Dilshuk Nagar, and web server 2 we can keep it into the Amirpet. Okay, so web server 3 we can keep in the Kphb. Okay, and web server 4 we will keep in the BHL. Okay, so these are the 4 areas. We are keeping the 4 different types of servers. Now our agenda is whatever the configurations we are doing in the Dilshuk Nagar server, we need to keep in the same configuration the Amirpet server. But usually what will happen? We are going for the manual process to achieve this, correct? We will go for the manual process to achieve this configuration. But if you want to go for manually, it is taking a lot of time and it may getting some kind of issues. So sometimes Dilshuk Nagar is working fine, Amirpet server will not be working. Maybe the compatibilities, software compatibilities, operating system compatibilities, etc. So in that scenario, how we can do? Let us assume this is not a, this is a goods. Okay, this is a goods. Usually, if I want to shift from one location to another location, what we can use? We are using the container, correct? We are using the container. Container is nothing but yes or no. Suppose if I want to moving house from one location to another location, we can keep all our things into the container. The same way, the application is also, the application will also keep all kind of configurations into the container. We need to packaging all kind of configuration. So that is called as a image. So here what will have, what was the solution here? So we can just make it like this. We can just convert all kind of configuration. Yeah, we can convert all kind of configurations into the images. So what we can do, we can keep this image into that, and these images we can move into the container. So like this, just spin off the image inside the container. That's it. So within fraction of second, your application is available. Your application is available with consistency. Because whatever the configurations we are doing in the Dilshuk Nagar, the same configurations we are doing in the Amirpet, the KPHP and BHL as well. Clear everyone? Any confusion till now regarding the continuous delivery? Yes, Chandra, tell me, Chandra. Yeah, someone is raised their hand. Chandra, tell me your question. Okay, fine. If you don't have any question, guys, we can go for next
Sir?
process. Okay. Yes, yes.
Sir, what is
Yeah.
the meaning of deployment?
Yeah, deployment is nothing but see, what we can do usually, we have the server where we can able to deploy our application. Deployment is nothing but see, every users, every developers are using in their own local machine, correct? Suppose we have the developers and we have the operation people, everyone is working on their changes into the local machine. So we need to test some kind of environment, correct? So we need to
Yes.
test all the changes into some server. That's why usually what we can do, we can, whatever the changes are doing every developer or every operation people, we can combine all the changes and we need to test into some kind of server. That is called as a deployment. Understand?
Yes. Okay, sir.
So when the testing is happening, then the QA people will come into the picture. They can able to test it like performance and everything will be taken care. If you get any issue, then automatically they will get back to us. Correct, na? Yeah, that's why we will go for. So clear everyone. So here the images will come into the picture and the container will be used. This is called as a application containerization. This entire process is called as application containerization. So who will help us to do the process? Here the Docker will come into the picture. Docker will come into the picture, and as well as Kubernetes. Kubernetes is nothing but orchestration of the containers. Orchestration of containers. So first one is Docker, Docker, and Kubernetes is nothing but orchestration of the containers. First one is Docker, and second one is Kubernetes, orchestration of the containers. So this is very important. Now coming to the process, the one more advantage, guys, whenever we are using the image based application, you no need to require 4 server. So within single server only, we can able to deploy. Suppose within single server only, we can able to deploy 4 kind of images. That is an advantage of the containerization. The cost is very reduced. The cost will be reduced here because same type of application, correct? The same type of application we can able to deploy into the within single server. We can able to deploy 4 kind of images. So this is called as application server. What is an advantage earlier? If you want to deploy our application, you need 4 server, but now within single server, we can able to deploy same kind of images. That way, this is an every advantage, guys. It's in the image itself. It can contain precompiled with all kind of application configuration, with all application configurations. Okay, clear now? So whenever we are running, the images are not running. Whenever we are executing the images inside the container, then automatically it will be executed. Correct na? So the container will take care the life cycle. So who will responsible? The Docker. So the Docker is responsible, the 2 responsibilities, guys. The first thing is to convert all application configurations into images, and second one is all these images will run inside the containers. All images will run inside the container. And third one is the most important point. So we can't directly access images. Only we can access them inside the container. So this is very important. Okay, so this is how we can able to, this is a continuous delivery. The main advantage is in single server we can able to deploy 4 kind of images, and the Kubernetes is nothing but orchestration. Suppose we deployed our application, guys. Okay, we deployed our application, so everything is fine. Let us suppose if something is went down, suppose application is down. Okay, let us assume my application is down. Whenever my application is down, so what will happen? Suppose it is down, what will happen? So you need to log into the server. We need to log into the server and you need to restart the application, correct? But when we are using the Kubernetes, guys, you no need to do those things because the Kubernetes will automatically taking care of these responsibilities. When the image is down, no need to worry. Automatically the Kubernetes will be recreated. Kubernetes will be recreated one more image. That's it. And not only for that, this is called as a fault tolerance architecture. Fault tolerance is nothing but if one server is down, so automatically the Kubernetes will be created one more server. And one more here, instead of the fault tolerance architecture, so there is a high scalability. There is a scalability. So whenever we are working on the scalability, right? So when you're working on the scalability, so automatically we can able to scale up and scale down the resources. Scale up and scale down the resources. So what is the meaning here? So let us suppose we have the 400 users. Right now the 4 images are fine. But all of a sudden, if you are getting 500 users, so one more image will be created by the Kubernetes. One more image will be created by the Kubernetes. This is called as a scalability. Okay, scalability, high availability, deployments. So that should be taken care by Kubernetes. That should be taken care by Kubernetes. So coming to the continuous delivery side, as per this here, so continuous delivery is a software deployment. So blindly remember to deliver your code into n number of server and to make the consistency. That's what we can call it as a continuous delivery. And coming to the microservices, guys. So what is the meaning of microservices? So microservices are nothing but to deploy microservices in the organization level. So nowadays, when we are working on the DevOps practices, so most of them we are using the microservices architecture because all of the microservices we are deploying them. Let me explain clearly. So how the microservices architecture, because microservices architecture we are not using practically, only the developers are using them, but we need to understand so how it should work. But we need to understand how it should work. So this is very, very important. This is very, very important. Yeah, this is very, very important. Clear na? Now coming to the process here. Yeah. So in the first initial days, 10 years back, so what they can do, they are deploying their application to monolithic servers. So this is called as a monolithic server. So in the monolithic environment, what they can do, this is the monolithic. Okay, so in the monolithic application, all kind of application services, guys. So there is a front-end application, back-end application, and middleware services. So front-end application, back-end application, and middleware services. See, all this application we are deploying into one single environment. Okay, so single server or single layer. Okay, we can say like that. So what was the problem here? Suppose if I want to change any front-end application, again we need to deploy entire application. Suppose if any due to the some backend connectivity, if you lost a backend connectivity, so automatically your application will be down. So this is the monolithic application to keep all configuration into single layer. To keep all configurations into single layer. So that is called as a monolithic application. So forget about that, how the functionality guys, because this earlier days, 10 years back, they are using the monolithic server environment. So this monolithic environment can contains all the configuration will be single layer. What was the problem here? What was the drawback? So when we are working on the drawback, right? So if anyone changes in the front end application, automatically rest of them will also be changed. If anyone changed into front end or back end configuration, all will be changed. All will be changed. So this is very, very important. So this process is called as a monolithic application. So next one is, okay, so I don't want to do like this. I don't want to do all layers into single. Then we will come under MVC architecture. You might be heard about the MVC, all right? Model view controller. This is called as a MVC MVC. Okay, so this is nothing but model view controller. So this is the view layer and controller layer and model layer. Right. So here, so we can say like this. This is called as a view layer. In the view layer, so we can say that HTML pages, right? HTML pages, HTML, and controller layer. We can do servlets, Java based or .NET based, anything. Okay, and here the model layer. So we can go the business components. Okay, so in this model layer, the business components will convert into the application. This is the model here. Okay, so blindly remember one point. Earlier days, we have the one single monolithic application. Then it should be converted into three things, right? Then it should be converted into three things. So this is very important. So after that, so there is a one more configuration here. So that is called it as a monolithic and MVC and microservices based application. So what was the difficulties here? So here also, at least some better compared to whenever if you want to change view option, view layers, you should not deploy our application. You should not deploy our application. But still, if you want to get any kind of upgrade or anything, we have the downtime. Then the trend in the market is microservices, guys. So how the microservices will work? Your entire application will be spin off into a number of services. Let us take we have the application, banking application. This banking application, the front end application, back end application, we can differentiate a separate mini services. Okay, let us take, so this is the front end. Front end application. And this is the back end application. We can say that, so instead of the front end application, and we can also say that payment service, loan service, banking service. Okay, so clear, these are different types of modules, or we can say we can convert all kind of modules, guys. Okay, instead of single application, so we can convert this kind of application into n number of pieces. This kind of application to n number of pieces, right? So when you are working on these kind of n number of pieces, automatically, so it should be treating as a separate application. So this is the API. We can connecting this into the API gateway. There is a one API gateway will be there. So this gateway will automatically connect with our application. So let us take, if anybody request only for loan service, he can able to do that. This API gateway API having the URL, right? So my app dot my banking app mybanking.com. Okay, so this is the mybanking.com. Now what I can do, if he required only for loan module, right, he can able to request only loan, because by using this URL. So in the browser, what they can do, so my banking app .com/ and loan service. So automatically the request will go to the loan services only, right? And if a front end service, payment service, and banking service. And what was an advantage here? See, if I want to get any down with the front end, no need to worry. Back end is going on. See, like nowadays the UPI concept, right? Whenever the UPI concept is coming, the application is all the applications are converted into the microservices architecture. So in the you might be having one doubt. So this is the developer. So what is related to the DevOps? So when you coming to the DevOps side, we just converted all kind of these microservices into images, and these images we are deploying them into the application. So that is an advantage here. And that will help us. So loosely coupled architecture. So this is these two are monolithic and MVC are the tightly coupled architectures. So when we come into the loosely coupled architecture, so most of the things will come under differentiate. Okay, that's why nowadays, if you see the banking sector, you should not see any kind of outage. You should not see any kind of outage in the banking sector, correct? So earlier days, if you say 10 years back, you will get a message like this. So today banking will be not available. So from Saturday to Sunday, the banking is not available. But nowadays, you should not see these kind of images, or we can say messages. Why we can able to see that? Because of the microservices architecture. Okay. So coming to here, so this microservices architecture we need to deliver. We need to deliver you here. Deliver. Next one is infrastructure as a code. So the Terraform, everything. So nowadays, because when the cloud will come into the picture, then we need to use the infrastructure as a code. So that will help us to automate each and every cloud environment. We are also going to work with the Terraform. During our sessions, I will also include you Terraform, and I will show you, I will take one scenario and I will show you how to generate the code and how to provisioning the services. And configuration management. So this is nothing but provision of the software, guys. So we have the bunch of servers, how we cannot. So configuration management and monitoring and logging. So we will discuss in the coming class. Tomorrow, what we can do. So tomorrow we are going to discuss the configuration management and continuous monitoring and the cloud necessity. What is the necessity of the AWS cloud, and how the work will be there, how the work culture will be there in the organization level, how the work culture will be there in the organization level. So that is very, very important. In any doubts till now? So let us discuss your doubts, guys. Any doubts? Chandra, Hema, Praveen, any doubts from your end? Guys, please tell me. Suppose if you guys are not asking any doubts, I may think that, okay, you understood very clearly or you didn't understand. At least speak out, or suppose if you are unable to speak out, just ping me in the chat. Any doubts? Okay, guys. If,
Sir,
yeah, tell me.
AWS DevOps and the AWS Cloud is different, or it is the
No, no,
same?
no, no, no. Let me tell you. See, AWS DevOps is different. So here, what will happen? So we are going to discuss the DevOps tools, whatever the DevOps tools, and along with that AWS Cloud. AWS Cloud. Got it now? So in the DevOps tools, we have the Git, Maven, Jenkins, Nexus, SonarQube, Docker, Kubernetes, Ansible. Okay, so these are the tools will be there. So these are the DevOps. Along with, we are also cover the AWS cloud technology. See, nowadays what happened? So we should not, the cloud and DevOps are two different technologies. If you learn only for one technology, you should not get more calls. Got it now? Clear?
Yeah.
See, Azure cloud is different. Azure cloud is nothing but Azure only, we are using Azure tools only. That's why the calls will be very less compared to this one. So here we are working, we are using the two tools, correct? AWS and as well as cloud. Got it now?
Okay. What type of coding we will use in this, sir?
Yeah, in this coding, we don't have any coding, guys. Okay, actually that's what I am saying in first day itself. So you don't require any coding knowledge. Okay, you can come directly here. So even the freshers can also learn, and experienced people can also moving from one technology to the another technology. So here we are just using the Groovy, JSON, okay, and YAML script. So those scripts are very simple. So just key value kind of configuration. When you execute one script now, you can understand very easily. Clear?
Yeah.
So don't worry, guys. See, this question is will be there in everyone, right? So once you join, once you started the AWS and DevOps, you need to coding knowledge is required. No, 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 no. You don't need to require any kind of coding language. Just we need to know the syntaxes of that. Okay. So that's all from today's class. So let's join tomorrow. Bye.